Okay, so before we start today's lesson and learning goal on common factoring, just do a quick review of our area model with algebraic expressions. So if you are asked to expand and multiply out this expression of 2x bracket x plus 4, we could set it up with this picture, 2x down the left side, x plus 4 across the top. And what we could do is we could use our algebra tiles, drag them in, and we can use it to find the values. We could also use our shortcut drawing the arrows. Okay, that would be another option. I'm going to just try and cheat here and clone these really quickly. But what we want to pick off here is that we were started on the outside and we worked our way inside, and that was expanding. Okay, so that was using the dimensions to find the area. Okay, so remember, these are the dimensions. Make sure I got a pen here. These are the dimensions. This is the area. So if we did this one would have 2x squared plus 8x. We could have also done this with our, 2x, yeah, I said that right. We could have also done this with our shortcut or our arrows. Okay, so now factoring. So by the end of today, I'll be able to determine the greatest common factor for a collection of numbers, and I will be able to common factor a simple polynomial expression. This is a big topic in grade 10, so we're just going to start the conversation now and get it in your minds. So factor means to use the area to find the dimensions of the rectangle. Okay, so when we do our area model, we're just working backwards, so it's the opposite of distributive property. Okay, the key thing is there may be more than one answer. And this is really important. So if I asked you to find the dimensions of a rectangle with an area of 16 square meters, okay, you would have several options. You could go 1 times 16, you could go 2 times 8, or you could go 4 times 4. And all three of those would be correct. And all of these values right here, 1, 16, 2, 8, and 4, those are all factors or multiplication blocks, building blocks of the number that we do through multiplication. Okay, so the instructions here are factor. So I've set this up just so you don't have to see me dragging a bunch of tiles. So I've made my rectangle, I've made my area, 4x plus 6. And now I want to do is work backwards to figure out what would be the dimensions. So to get an x here, whoops, let's start that again, get back on and delete that. Okay, so let's try that again. To get an x, we would need to have dimensions of x times 1. Okay, and we could do that twice. And then we'd see we have the same value over here. What's going on here, computer? Work with me. There we are. Come on. All right, it's going to be fussy, I can see. All right. Come on. All right, close enough. Okay, then I'll drag the ones up. And we would see that our 4x, boy, must be late at night. 4x plus 6 has dimensions of 2 times 2x plus 3. So the 2 is right here, this is the 2, and this whole term along here is the 2x plus 3. So you'll notice we went from the area to the dimensions, or I undid my distributive property. That's what factoring is. Okay, so now if we started something a little more complicated, 2x squared plus 6x, again I've laid it out already just to keep it a little bit quicker. Hopefully my computer will work with me here. Oh, it's going to be one of those nights. Alright, so let's try this again. We drag up our x. So to get an x squared, I would need an x times an x. That gets me an x squared. Okay, so there we have our left side created. To create these 6 green x's over here, I would need some 1's. So I'm going to put those up there as well. And now I just do a quick check. Do all of my dimensions produce that area? And if they do, I now know the answer here would have dimensions of 2x times x plus 3. Okay, so if you look here, this area up here became these dimensions. And if you did a quick check with your distributive property, 2x times x would be 2x squared, and 2x times 3 would be 6x. Okay, so all we're doing is undoing our distributive property. Okay, now in the interest of speed, I've already filled this one in on both the area and dimensions, so just we can have a quick look. If I want to create this area right here, my dimensions would be 2x on the side, and then 2x minus 5 on the top. Okay, and if we did a quick distributive property, we could see 2x times 2x is the 4x squared, 2x times negative 5 is the negative 10x. Okay, so the algebra tiles give a really nice way of exploring and seeing what you're doing. So if you want to pause it here, you can try these two on your own. Just draw pictures, try whatever you like, and see if you can come up with the two dimensions that give these two areas. Okay? Okay, so hopefully you've had a chance to try that. So I already have some of this started just to make it a little quicker. I have my 6x's. Oh, I don't want to circle that. I'm going to take my 6 ones here and clone them. I left one group off. So there's my 12 ones. So now if I want to create, okay, I can try and put that guy there, but there's a problem. Okay, if you look at the dimensions here, these dimensions, they don't match up. Okay, so the only location for that guy to go is I'd have to rotate it and put it on the top. And again, this is why these are really handy, these pictures, because they help keep everything in control. Okay, so you can visually see what's going on and you can see your mistakes and then make the adjustments. Okay, so I'm just going to drag these up as quick as I can. And again, there will actually be more than one answer with this question, so I'm going to write down all of them for you, but I'm going to do this one first. So this one here, if we look at the solution, okay, we would look at 1, 2, 3, 4, 5, 6 down the left side, and then x plus 2, okay, across the top, and that would be a correct answer. But just so you know, there are other options. You could have 1 times 6x plus 12, which is kind of a trivial solution. Okay, you haven't really done anything. You could take out a 2 and have 3x plus 6. You could take out a 4. Can you do a 4? No, you can't do a 4, sorry. You can do a 6. Or you can do a 3, pardon me. You can do a 3. And that would give you 2x plus 4. And so when you look at this, there are actually 4 answers, just like the first question we did today. There are 4 answers to this problem. And that's okay. All right, now this one's kind of big and scary. I've laid out most of it, what you can see, and I'm probably just going to write the answers in here because it'll be a little faster. I have a whole bunch of x squared terms, and I have a whole bunch of negative x's. So if I look at this, this is going to be x minus 2, and down this side I would end up with 5 x's. And as you get more familiar, you're able to shortcut these pictures and jump to the answers. So here's my 5x, here's my x minus 2. If I do a quick check, something like that, 5x times x would be 5x squared. 5x times negative 2 is negative 10x. Okay, so remember, the pictures are just guides. They're just there to help you out. Okay, so now the greatest common factor and finding the GCF is where we're going to sort of strive towards and try and get under our belt. It's a shortcut technique. It's an algebra technique. It's a little faster. Okay, so let's start here. Factors are numbers that act as building blocks to create larger numbers. Okay, so through the operation of multiplication. So you could have 12, and factors are 4 and 3, because if you multiply those together, you get 12. You could also have factors of 6 and 2. They would also get you to 12. Okay, and then we have something called prime factors, and prime factors are just multiplication building blocks that use prime numbers. Okay, so a quick refresher, prime numbers are right here. 1, 2, 3, 5, 7, 11, 13, and on and on and on. We really only need the highlighted versions. So what we'll do with 12, for example, and you've probably done this with factor trees. You might have seen something like this in your past. You would go 2 and a 6, and then you would break the 6 down into a 2 and a 3, and these three terms here would be your prime factorizations, I believe is the expression. You can also write it out in a line. Okay, so 2 times 2 is 4 times 3 is 12. You can take as many lines as you need to break these down. 36, for example, you might do it this way: 36 equals 9 times 4, and then you might break the 9 down into 3 times 3, and the 4 into 2 times 2. That's totally fine. Okay, so the greatest common factor is the largest factor, okay, or building block that's shared between two or more numbers. So if we looked at the greatest common factor for 18 and 27, the biggest building block that they share would be a 9. Okay, so you can see this. 18 is 9 times 2, 27 is 9 times 3. And I'm going to show you a way we could find this without having to have any guesswork at all. Okay, where this starts to become tricky is when the numbers get bigger. Okay, so this is what we do. Here are my three numbers: 24, 48, and 60. And you might be able to say the number right away. That's awesome. If you can't, this is how we're going to approach it. You're going to break them down into smaller pieces. And I'm not going to read these all to you. You can pause it and look at this in a minute. And I'm just going to keep breaking them down until I get to their prime factors. And once I get it all the way down to their prime factors, what I want to do is just highlight what is shared. What do they all have in common? So do they all have a 2? So you underline it and you say, yes, they all have a 2. Do they all have another 2? And they do. Do they all have a third 2? Well, 24 does, 48 does, but 60 doesn't. So there's no third 2 that they share. Do they all have a 3? And they all have a 3. And there's nothing else in common. Okay, 24 and 48 don't have a 5. So when we look at this, you can see I've highlighted this already. So 24, there's the 3, 2, and 2. 3, 2, and 2, 3, 2, and 2. And when you multiply those together, you get 12. And 12 becomes the greatest common factor. It's the greatest shared multiplicative building block between those three numbers. So does it work if we have expressions like a squared, a's, and a cubes? Well, it does, because a's are just numbers we don't know. So we do the same process. We take our terms, we break them down into their prime factorizations. We break all the way down to the prime numbers, and then we highlight what do they have in common. So if you look, they all have an A. Okay, they don't have anything more than that. They have, I see, at least 2 2's. Okay, and then I don't see anything else that they have in common to all three of them. So the greatest common factor is 2 2 and an A for all of them. And when we multiply that together, we get 4A. So the greatest common factor for these three terms is 4A. Okay, so that's the approach. Okay, so if you want to pause it and try this, okay, 16, 24, and 40. I think I did that one already, actually. Maybe we'll skip that after all. No, we did close. So this one's yours. Pause it here and see if you can come up with them. Okay, so I'm going to start with 16. That's an 8 and a 2. That's a 4, a 2, and a 2. That's 2 times 2 times 2 times 2. Okay, and again, your multiplication facts, as they get better, you get faster. Okay, so 6 is 3 times 2, 4 is 2 times 2. That's as low as it goes. 40 is 8 times 5. 8 is 2 times 4 times 5. And then this is 2 times 2 times 2 times 5. Okay, now we just highlight. So what do they have in common? I count 1, 2, 3, 1, 2, 3, 3 2's in all of them. So 3 2's multiplied together. Okay, so this would be 8 would be our greatest common factor. Cool, and it's that easy. So as you get more comfortable with your multiplication facts, starts to go really fast. So again, pause it, try it here. Okay, and I'm going to jump ahead just because writing it all down here, if I do it in all the steps, it'll take a little bit extra time. So I'm going to go 2 times 3 times 3 times a times a. And again, I have a different comfort level than you, so that's totally okay. 27 is going to be 3 times 3 times 3 times a, and 45 is going to be 5 times 3 times 3 times a, and an a. Okay, so now we highlight what do they have in common. So I see 2 groups of 3's in all of them, and I see 1a in all of them. So what would they have for a greatest common factor? It would be 3 times 3 times a, or 9a. Okay, so how do we bring this all together? Find the dimensions of the following, and we are going to avoid the area model. Well, we're going to take the greatest common factor approach we just did, and we're going to utilize it. So we're going to break 4x plus 6 down into its 2 dimensions. So we're going to break the 4x over here, and I'm going to write the 6 as well. If I break 4x down, 2, 2, and an x, and I break the 6 down, 2, and a 3, I can now highlight what they have in common. And it's a 2, so I would write that in the first bracket. Anything that's not highlighted goes in the second bracket. 2x plus 3. And if you did a quick distributive property, just to check your work, you would see this becomes 4x plus 6. We know we're right. Okay, so let's try this one. I'll do 2 like this, 2 more like this. So again, we go off to the side. I'll just make an outline here. We take our 2x squared, and we take our 6x, and we write them down as primes. So this is 2x and an x. This is 2, 3, and an x. Now let's highlight what they have in common. They both have 1x. They both have a 2. So your greatest common factor, probably shouldn't write in yellow, is 2x. So it's going to go in here. Anything that is not highlighted goes back into the bracket, x plus 3. And if you did a quick distributive property, you could do a little check. This would be 2x squared plus 6x, and we would be correct. Okay, so we're going to finish up here. If you want to pause it and try this one on your own, that would be a great move. So 4x squared and a negative 10x. Okay, so the 4x squared becomes 2 times 2 times x times x. Now there's something here we have to really watch with this negative 10x. We're going to control the negative sign by putting a negative 1 there. If we don't, and we write this as one of the factors as a negative 2, we will miss what they have in common. Okay, so always when this is negative, just put the negative 1 out front. Makes your life way easier. And now let's highlight what they have. They have an x, they have a 2, so our greatest common factor is just 2x, so that goes out front. And then anything that's not underlined goes back in the bracket. So there's a 2x from the first term. And then I got to watch the negative times the 5 is negative 5. And again, do a quick distributive property. And you get 4x squared minus 10x. And hey, look at that. We're right on all accounts. Okay, so you have a little task for factoring. Again, this is not a huge part of grade 9. This is definitely a lead-in for grade 10, but this is the opposite of distributive property, so it's good to learn a little bit about it right now. Thanks for tuning in.